Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, we're going to continue talking about control flow structures, this time talking about a for each loop. Now, for those of you who've worked in Python or maybe other languages, even C++ with range-based for loops, this is D's equivalent, and it's just a really elegant way to allow us to program. So, with that said, let's go ahead and take a look at for each loops in the D programming language. So in order to understand this, what I'm going to go ahead and do is just take you to the documentation page. So go ahead to documentation, language reference, and you'll find this page here and the whole table of contents here. And then I'm going to go ahead and scroll down to statements where I previously was. And if we go ahead and click on number 11, you're going to see all the things that we can do with for each statement. So we're going to cover a subset of these just to give you an idea of what they are. And if you're new to programming, you'll be right at home here. And if you're new to D as a language, this will also be a great place to start with some of the examples that I show you. But what I want to go ahead and do is just kind of scroll through this list and show you that there's a number of interesting things that we can do with for each, for instance. So we can go ahead and use it with loops, and I'll go ahead and compare that to how we've been doing loops before. For each works with things like arrays, with associative arrays, strings that we're going to learn about, and associative arrays again that we're going to learn about, and even with classes where we're going to be able to implement with something called op-apply, which again, stay tuned with that. And then there's this greater idea of when we're iterating through something with, well, how do we iterate through data structures? So luckily, a lot of the built-in data structures in D, which we're yet to talk about in this series, things like lists, for instance, are things that we can iterate through nicely with for each. But even if we define our own classes, we can use for each. So with that said, just want to give you a little bit of a preview of some stuff to come, but let's go ahead and start with the basics here and go ahead and learn a little bit about how for each works. So I'm going to go ahead and just open up a file here, and let's just go ahead and create an array. And I'm just going to go ahead and make this an array of integers, my data, and let's just go ahead and set up some numbers here. 1, 2, 3, 4, 5, 6, 7. That should be sufficient to play around with. Now, previously, what we've learned about in D as far as loop structures is to just create a for loop here. So I'd say something like for int I equals 0, while I is less than my data dot size, I plus plus. And then I might write line out here, my data at I here. And then let's go ahead and run this with RDMD for our main program. And again, just being a little bit careful here. Looks like I don't have that property here. So length of our array, there we are. And now we can go ahead and print things out. Okay, so again, this is sort of a standard way to write a loop. There's nothing per se wrong with this, but the sort of stylistic thing that we like to do is to instead use a for each loop. And I'll go ahead and explain a little bit why. So using the syntax for each, and then we specify the element that we want to refer to, and I'll just refer to this as maybe element, and then a semicolon in the D programming language, and then the collection of data that we want to, again, iterate through. Okay, so let's go ahead and try this, and I'll go ahead and write line and element here, representing my data at each of the indexes here, a semicolon, and I'll go ahead and run this, and you'll see that we get the same thing repeated. So both of these loops are representing the same thing. I have a collection of data, my data here, and I want to iterate through the entire collection, thus I less than length here. But we like for each loops in general because they're defining the range of computation, which by default here is just saying, hey, when I see a for each loop, I want to do for every element that exists in my data some operation. I'm applying some operation to it, which is where that op-apply comes from, which we'll talk about later. But in this case, we're just writing a line here for our element here and outputting that to the console. Okay, so that's the idea with using a for each loop. Now let's go ahead and refactor this a little bit. I'm going to go ahead and get rid of this here. And maybe we want to actually do some operation on every element in our for each loop. So what I'm going to go ahead and do here is actually access the element here. And maybe let's just add 2 to each of the elements and let's write it out here. So I'll go ahead and run it. And just like that, we can see that we're printing out whatever the element is in my data and adding 2 to it. Now we have to be a little bit careful here, because what I'm going to go ahead and show you here on my screen here is I'm going to go ahead and copy this loop here. And let's just say later in our code, so somewhere later in our code, we do many things here. And then I just want to go ahead and write out this actual loop here. So let's go ahead and run it out. And interestingly, I see 3, 4, 5, 6, 7, 8, 9, appropriately adding 2 to each of these elements. But when I print out my data, I get 1, 2, 3, 4, 5, 6, 7. So, did I add 2 to every element here? I thought that's what I did. Well, in a for each loop here, what we're actually doing is making a copy of the element that we're accessing here, and then doing some sort of operation on it. So that's the default behavior in the D programming language, that I'm not actually modifying this actual element or the data that sits in my data. In fact, I'm making a copy of each of these elements as I iterate through one item at a time here, the 0th index, the 1st index, 2nd, 3rd, 4th, etc., through all the elements here, and then I'm making a copy of it and then adding 2 to it. So this brings up some interesting design decisions that, well, depending on where you are in your programming career, matter more or less, right? This idea of how expensive is it if I'm making a copy of every element? What if this collection had 1,000,000 elements? What if those elements are really big? And those are some things you'll have to think about in your programming journey. But let's just go ahead and continue with the basics here in this series and say, well, what if I actually do want to modify and preserve those changes? Well, we have a keyword for this, and for those who are coming from a C++ background and know about pass by reference, we can say, hey, I want to refer to each of the elements here, or refer to the actual reference, the actual element that exists here. And then that's what I'm going to actually modify. So I'm accessing this data by reference is a way to say it. Okay, so let's go ahead and run it again here. And just to make our output just a little bit neater here, I'm just going to write an empty line here, just so we can get a blank space here. And now we can see the second time when I go ahead and print out these elements, 3, 4, 5, 6. Again, it's still printing out a copy of the elements, but this first pass through, I'm modifying the loop. So let's go ahead and just put a note here. With ref, I modify each of the elements. Okay? Elements. And then here, without ref, I'm accessing a copy of each element one at a time in my data. Okay, so I hope that makes sense. Again, with whether we want to actually change the data or just look at the data. And again, this could be a really nice thing because it's very clear what we want to do just by reading this one line here at line 8, saying, well, I want to do something and modify each of these elements here, or I just want to, again, observe everything in this collection. All right, so with that said, let me go ahead and just show you a few other nice things that we can do with for each. So sometimes we don't always want to iterate through our data structures forward. We might want to go through and iterate backwards. So another way to say that is just to say in reverse. Okay, so I could do for each in reverse, and let me go ahead and do this here. And that'll go ahead and look through a collection, or in this case, an array, associative array, different types of containers backwards. So again, observe that we are going through backwards this time, looking at the last element here, which we've of course modified by 2. So we have for each and then for each reverse. Again, the actual mechanism for doing this is something that we're going to talk about later in this series, known as iterators. So if you're interested in that, go ahead and comment below, and maybe I'll push that a little bit earlier in the series as far as planning out my lessons here. But again, the idea is that we have, with a for each loop, which I'll go ahead and illustrate here, my data. So let's just go ahead and look through this just one more time, illustrating what we've covered, and then we'll call it a day with this lesson here. And then for each is basically saying, okay, I want to do something to each of these elements. So I'm going to look at them one at a time here. And in each of our loops, we're just going to refer to that element here. And I'm able to figure out the type here. You'll notice that I'm not even specifying, hey, that this is an integer or anything of that matter here. D is smart enough to infer what the type is. If we wanted to explicitly refer to it as some sort of type, or maybe cast it or do something like that, we could do that. But again, we don't need to. D is smart enough to just say, hey, I know this is an array of integers, so I'm just going to make element in integer here. Okay, so again, what we're doing in our for each, accessing every element here, and we can also do this access backwards here using a reverse iterator, or for each reverse. Okay, so for each by default starts from the beginning, or we can access the last thing at the end. Now, again, depending on your programming experience, and if you're coming from a language like C or C++, you might have some idea about how we are using iterators. And we have forward iterators and backward iterators as well. So I'll just kind of label these here. backward or reverse iterators that allow us to define how we move through this structure. Now, why does this matter, this concept of just using a for each to traverse through some collection, when you say, well, Mike, it was pretty trivial to do that with a regular old-fashioned array with for, int I less than, the collection size, I++, or something like that. Well, what if I give you data structure that's a graph, something that looks like this? Maybe it's a tree. Maybe it's got cycles in it, but you still want some way to actually iterate through this data structure. And that's where we have to define what it means to move forward or in reverse, or maybe just access things randomly with these things called iterators. Okay, so that's the basic idea for working with for each loops. Now go ahead and show you one other cool thing that you might want to do in D, just because, again, if you're coming from languages like Python or others, you're probably familiar with for each loops here. So let's go ahead and just move this example down here. And I can actually do for each number here, semicolon, and then actually just specify a range in this way. So 1.6 here, just pick some random number. And let's just go ahead and try to right line this number here and see what happens if we run this. And let me go ahead and give myself a little bit of a space here by doing a right line to get just 2 lines, just so you can see exactly what that example was doing. But I think you might get the idea that we're actually able to print out a range of numbers here, 1, 2, 3, 4, 5. Now that's not inclusive of 6 here, but again, this might be a nice thing that you're trying to do if you're just trying to generate some data, populate a collection, etc., etc. We can just do this like range in Python, for instance. So that's one cool thing I want to show you. And then the other one, I just want to go ahead and make concrete, because we've talked about this in a previous lesson. Let's go ahead and just create a string here, Mike, and I'm just going to refer to this as C for each of the characters here. And again, give myself a little bit of space here by putting in some empty lines. And remember what a actual string is here, okay? M-I-K-E. Well, string here, the type here, is just a immutable array of characters. So we've learned what arrays are previously in this series. We know what the individual characters are and what a string is. So again, we can just iterate through. It's just the same thing as an array, except I'm not using numbers this time. Okay, so just some cool things that I wanted to show you that I think you can play around with a little bit. And again, if you want to actually modify these characters, well, then we need to make some changes here. And again, use our little trick that we learned about with ref. All right, folks, I hope that was an interesting lesson. I hope you now start to use for each, especially if your intent in your code is to actually iterate through everything inside a particular collection. I think it's just a very clear way to do syntax. And we haven't gotten into some of the other cool stuff that we can do in the deprogramming language, where we can do for each and then use parallel at the end, so we can actually do parallel computation. And again, for each allows us to do this relatively trivially when we want some more performance. So more things to come in the deprogramming language and in this series, so make sure you subscribe so you don't miss it. And as always, thank you for your time and attention, folks, and I'll see you in the next episode.